Good day everyone. I am S. Brinda, Assistant Professor from the Department of Civil Engineering at Kamaraj College of Engineering and Technology. Welcome to the lecture series. We have been introducing the basic commands, analysis and design details of various structures right from the basic models to the specific and unique models. Today, welcome again for the analysis and design of a 2D frame. Let's get into the introduction part. What is a frame? We all know frames are the reinforced concrete structure comprises of beams, columns as well as slabs, the entire loads being distributed to the final base as foundation. We know the function of beams, columns and slabs individually. It is very important when the frame is being constructed after G+2 stories because wind load and seismic effects also to be included. Now, we shall see how analysis and design shall be done for a 2D frame. There are two types of frames, rigid as well as braced frame. We know everywhere we shall see the general frames which are constructed as rigid. There are some structures which are constructed with braces. The purpose of adding braces is to avoid the collapse. Adding braces to columns is to avoid buckling of columns as well as indefinite or immediate collapses or to avoid unexpected collapses. We now open the model. So, we are using STAAD Pro Connect Edition. So, give the file name accordingly. I am providing us frame. So, I have taken the location to be saved and the units should be in metric. Create a model. Now your workspace is ready. You know the basic uses of all these commands. As usual, you should go for grids. I have generated the basic grid, rectangular grid. So now in the Connect Edition, we should give the grid option, or if you are comfortable with providing the values, you just go with the nodes. Okay. So, I have created a node. Using the single node, we shall produce multiple nodes equidistant or with eccentric distances. Now, you select the node cursor, your node is selected. Now, we shall use the paste option, Ctrl V. You should provide the nodes to be pasted along X, Y or Z direction. Now I am going with an offset value of 4 meter along Y direction. Click OK. Now another node has been created along Y direction at a distance of 4 meter. Now select both the nodes. Again, redo the paste option. Paste the nodes with an offset of 6 meter along X direction and click OK. Now your two beams were been offsetted along X direction with a distance of 6 meter. Now click the front view. The 4 nodes are visible. Click on geometry. You get add beam option. Use the command to join 2 nodes to create a beam. I am adding beam to the next part as well, connecting the 2 nodes. It is quite easy. So we have created 2 columns and a beam which forms a frame with a single bay. We shall provide loading now. Before going into loading, we shall assign supports. We create support. Usually column has fixed support, so I have created fixed support as default. Now again I have taken a pinned support also. Now it's time to assign the supports to the respective nodes. I am using cursor to assign option to assign. So I have created the fixed support for the left side node and it has been assigned, and now it's time to fix the pinned support to the right hand column, right hand side node. Actually the nodes were being numbered, it is not visible here. You can see a fixed support as well as a pinned support has been created for both the column bases. Now get into the properties. You just click the property. We shall give a rectangular model with depth of 0.45 meter and width as 0.3 meter, that is 300 mm. Now add, it is a concrete beam. Again choose a circle with diameter 0.4 meter for column. I have assumed circular columns here. We know how to design the rectangular columns. Now it's our turn to model a circular column. So click on the columns and select column assigned to the selected beams. Now your columns were being assigned with its property which we have already given, and as usual we can select the beam with the rectangular shape and its dimensions. It is denoted as R1. So you can check whether the properties are being assigned. Here you can see the thickness. Now the property has been assigned successfully to both the beam as well as the 2 columns. Let us move on to load case details inside loading option. So as a default one, you shall provide dead load inside the dead load case and add. Again take live load, provide live load as title and add. Now you have load case details with dead load and live load options. Again select self load. You should provide the values of self load. Along y direction it is -1. The direction is important because loads are acted along y direction. So now assign. Now provide the details of loading for live loads. So minus 45 kilonewton per meter is the UDL force I have assumed. So go to uniform force under member load. Now add concentrated force of 35 kilonewton along GY direction. You should provide -5 because the value is very important when the load is being acted along downward direction. I have created concentrated load along y direction from downwards to upwards. It's time to assign all the loads. You just proceed with assign to selected beams. Your beam has been selected and it has been assigned. You can check if the question symbol is not there, then you have assigned all the details to the structure. So now it's time to assign the concentrated load. You can see the loading values while we have assigned the self weight. Now click both the columns. Actually, we made a mistake. Along global x direction, that is the horizontal force, we need to assign, that is sway force. Usually we do concentrated force along y direction, then minus signs should be provided. But now we have assigned the concentrated force as sway force. So no need to provide minus. But for this column, you just check it out. We have provided initially along y direction. Actually, we need to change it as load being acted along x direction. We should give minus 35, then only the load pattern, the load will get acted from right to the left. So from left to right, you need not provide any sign conventions, but for the load acting from right to left, you need to provide minus convention. You can see all the three set of loads were being assigned along with the self weight. Now go to analysis, all option, add and close. You can run. Structure will get analyzed for a moment. So I don't need view output file, so I skip view output file and go to post processing mode. Now get into the design. As there were no warnings, I am directly getting into design option. So I am creating a concrete design. Just click it and your code should be selected as IS456. It was an ACI, so you should change the code as IS456. Bring all the available parameters to the left side and you should select the needed parameters to the right side by clicking the single head arrow. If the double headed arrow is selected, then each and every parameters will get moved to the right side. So we have selected FC, compressive strength. I am feeding the value of 20,000 kilonewton per meter square, as I have taken M20 as grade of concrete. Then I have taken reinforcement. For main reinforcement, the yield strength I have assumed as Fe 4 and 5 grade steel. Then the yield strength will be, I have taken Fe 500 grade steel, then grade steel, then the value will be 50,000 kilonewton per meter square. And for Fi secondary reinforcement also Fe 500 grade steel. Just add all the commands, add beam and add column and add takeoff. Now add all the parameters. Now it's time to assign all the parameters to the structure. For column only, you should select only the column members. For beam, you should select only the beam. Do not add the beams to the entire structure. Do not add columns to the beam. So just assign remaining things to all the members, excluding beam and column takeoff, and remaining things should be assigned to all the members comprising beam and column. Now assign to the entire beam. Go to analysis, Like previously we did in analysis part, after designing also we should go to analysis and run analysis. Your structure is ready for the analysis. Now we didn't get any error but with fewer warnings. So go to post processing, take all the load cases, add it. You can see the deflected structure of your beam as well as column. I am going to animate part. You can give maximum, minimum, ends, midpoint, everything. You should annotate. Then the values of your bending moment and shear force along the beam as well as column will get reflected. That is along the point of contraflexure as well as the column junctions you can see. So the moment along Z direction, you shall check the difference. Shear forces are also visible here. So I need the results for beam. Only for shear force at the ends, not the bending. So I have removed the bending at the ends, and again I annotated your results for analysis of beams is ready. So go to analytical modeling. Again you check a single member, maybe it is a beam or column. Click on to the concrete design. You can see the details of reinforcement provided along the top and bottom of your beam, and the space along with the spacing, with the moment, load pattern, everything you can check it. For individual member, whichever you wish to get the details of characteristic strength, reinforcement detail, length, breadth, depth, everything you can get in a single report. If you need, you shall click print. I don't need print option, then I am closing. Here you can see the detailing of column. We have taken a circular column for design. You can check the rebars provided along the circumference of the column with the entire load details as well as moment details. So again I am analyzing, view output file. So I need the output file, that's why I have analyzed again. You can check no errors were found and no warnings were found, only with a noted message regarding concrete quantity. Okay. So you can check the entire analysis and detailing after designing of beam, you can check. So the frame comprises of total applied load, total reaction load, applied concrete design for beam and column. You can check here. That is the main reinforcement as well as tie reinforcement, that is secondary reinforcement. You can get in the report in a single stretch. Added advantage of using this report is you can get the required concrete area and the steel area also for this column to be placed at site while it is being constructed or initiated. So it will be a warning message, or it will be a supportive clue for an engineer to proceed with the construction. So you can see the bar diameter and its weight. So for estimating the quantity, it will be useful. while presenting the final report. So that's all about the analysis and design of a 2D frame. We have taken a single bay frame. We haven't moved into those 2+ doors. We have taken the basic model with a single bay comprises of 2 columns along with a beam. We can proceed with number of stories along y direction as well as the base along the x direction also. Thanks for watching.